Greetings, math fans. All right, so this is chapter 12. We don't really use our book anymore, but it's right here, chapter 12. And our title of this is actually called Logarithms. So log, A-R-I-T-H-M-S, logarithms. All right, so it's a topic you guys really have never heard of before. And basically what a logarithm, and we abbreviate that, by the way, as log. Okay? And like I said, you haven't really seen this before, but basically what logarithms do, it's used to describe large numbers. Okay, so used to describe really large numbers. And so what is it? It's kind of like the opposite of exponents. So what we're going to be doing is we're actually going to be converting from log form to exponential form or exponent form, and then vice versa, the other way around. Now, where do you even use logs? Probably the best example is if you are talking about an earthquake, and there's something called a Richter scale. The Richter scale is a logarithmic scale. So if I have a 5.0 earthquake, which is a pretty severe earthquake, and then I have a 6.0 earthquake, the difference is not just 1, it's actually 10 times more powerful. And then if I go from a 6.0 to a 7.0 earthquake, that's also 10 times. So to go from a 5 to a 7, that's 100 times more powerful earthquake. Okay, so people don't realize how much more powerful going from 5 to 7. They think, oh, it's just 2 points. It's actually 100 times more powerful. And again, I can say, and here I can say 8.0, that's 1,000 times more powerful. Because 10 times 10 times 10. And then even a 9. That's happened, 9.0s have happened a couple places. This is basically wipes, if you have any kind of buildings, this is 10,000 times more powerful. This pretty much eliminates all buildings. Okay, it just knocks everything down. It's just a brutal, brutal earthquake. Okay, and so we've had a couple in Alaska that are, I think, 9.3, 9.4, which is like 10, 15, it's like 15,000 times more powerful than a 5.0. Brutal earthquakes. Okay, so anyway, that's kind of what it's, this is really like using a log scale. Okay, so let's kind of start doing some math here. And what we're going to do is I want to talk to you guys about converting between logs and exponential. So converting between logs and exponential. So this is what I'm going to write here is like super, super, super important. You need to put like 18,000 stars around this, but I'm going to use some letters first. So a to the b equals c. That's an exponent, right? A to some power equals c. Okay, and then also, so this is exponential because it's with an exponent. And then the log one is log base a. We said that's base. So that bottom number is called a base because it's like the lower part, like a building. The base of a building is the foundation, the lower part. So log base c is equal to b. So this is in log form. Okay, so again, I'm going to put lots of stars around this because that's like super important. And so basically, you're going to use this, math fans, to convert between exponential and logarithmic. So as long as you have this on your purple sheet, you are kind of good to go. Because let me just give you some examples. So I'm going to try and fit a lot of stuff here. I'm going to actually cursor down one notch here. Okay, and just go up a little bit. Okay. So if I write 2 to the 5th power is equal to 32, and I ask you to convert it to exponent, or that's an exponential, I ask you to convert it to log. Okay, look at the letters. A is 2, B is 5, and C is 32. So you're going to write that as a log base A, which is 2, of C, C is that 32, equals B, and B is the exponent, 5. There we go. That's it. That's all you have to do. Log base, and we say this, log base 2 of 32. So let me write this out. Log base 2 of 32 is 5. That's how you say it. Log base 2 of 32 is 5. Okay, so here's another one. 10 squared. What is 10 squared? It's 100. So let's write that in terms of log. So it's log base, right? It's going to be that the big number, right? Log base 10 of C, which is what it's equal to at 100, is equal to 2. Okay, it's, again, if you have this written down here, it's super easy to convert. Super, super easy. You just plug the letters in. That's all you do. Okay? So how about 3 to the negative third power equals 1 over 27. Okay, let's convert it to logs. It's going to be log base 3 of 1 over 27 is equal to negative 3. Okay? That's it. That's how you convert. So that's pretty easy, right? To convert to log. Now let's go the other way around because you have to convert. I want to convert now to exponential. So this was log, or this is, sorry, this is exponential to log. So exponential to log. Now I'm going to do log to exponential. So I'm going to erase this so I can fit it in here and keep that red box there. Okay, so I'm going to pause this for a second, but I'm going to erase it. Okay, so we're going to do log to exponential. So I'm going to give you the log. So here it is. Log base 2 of 8 equals 3. And you have to write it as an exponential. So again, look at the letters. That little number, that 2, that's my base. The exponent is the b, which is 3. And the c is that big, the 8 basically. And that makes sense. Isn't 2 cubed equal to 8? 2 times 2 times 2 is 8. So there we go. That's my answer. Okay, pretty easy. Let's do another one. Log base 4 of 16 is equal to 2. So, again, it's going to be 16. Sorry, it's going to be, let me write that down. Sorry, it's going to be 4. Okay, that's our base. So it's 4 to the second power equals 16. Okay, and 4 squared is 16. Works. Okay, so if I give you something like this, x equals log base 3 of 8, it confuses people a little bit because you're used to this. Log base 3 of 8 equals x. I just flipped it around, guys. It's not a big deal. It's just easier if it's flipped around. Log base 3 of 8. So if I write that as 3, so let me convert it now. 3 to the x equals 8. That's exponential form. Okay, so this is okay, but I rewrote it like this, so it's much better than that. Now it's easier to say, oh, 3 to the x equals 8. Okay, so that's converting, and that's, you'll see it on your worksheet. Convert from exponential to logarithmic, and convert from logarithmic to exponential. Okay, so the next thing is we're going to do is I'm going to have you guys solve. Okay, you're going to solve for x. So if I do that, we're going to solve. That's the directions. And it's going to say log base 3 of x is equal to 2. Okay, and math fans, before you can solve this, you have to write it. So must be written in exponential form. It's got to be written in exponential form. It has to be. Okay? So, again, let's convert it. It's 3 to the second power equals x. Okay, it's easy. What's 3 squared? 9. That's my answer to this problem. 9. What? That's it? Okay? Not bad. Okay, again, it's got to be an exponential form. Because if I gave you this, how do you solve that? 3 to log base 3 of something is 2. I have no idea how to solve that. But man, you throw that in exponential, 3 squared equals x. Oh, cool. X is 9. Super easy. Here, let's look at another one. Log base 4 of x equals 2. Okay, write an exponential. 4 to the second power equals x. What's 4 squared? 16. Oh, I'm done with the problem. What? Here's another one. Log base 5 of x equals 3. Okay, so you're going to say 5 to the third power equals x. So put that in your calculator. I don't care. 5 cubed is 125. And you're doing 5 cubed, right? It's 5 raised to the third power. Make sure you put that in your calculator. Okay, but anyway, my answer is 125 for that problem. Okay, let's do a couple more solving ones. Log base 7 of x equals 0. So 7 to the 0 power equals x. What's 7 to the 0 power? A lot of you guys are going to say 7, or you're going to say 0. Boo! 7 to the 0 power. Anything to the 0 power is 1. And the reason it's 1, think about it. If I did, this is from back in the day, if I did x squared over x squared, do you remember what do you do with the exponents when you divide? You subtract them. So isn't it 2 minus 2? So isn't it x to the 0 power? And what's the same thing over itself? X squared over x squared is equal to 1. So that means x to the 0 is equal to 1. Okay? So you can always type in your calculator 7 to the 0 power, right? 7 raised to the 0 power, and you'll get 1. But anyway, that's the answer to this problem, 1. Okay, then the last one, if I said log base 16 of x is equal to 1/4. Write it as an exponential. Okay, 16 to the 1/4 power equals x. That's a little tricky. Okay, type it. You're going to type this in your calculator. 16 raised to the 1 divided by 4. Please put that in parentheses. Try it. Hit pause and try and put it in your calculator. So 16 to the 1/4 power will come out with 2. Okay, so that's what it is. X equals 2. Okay, so that's evaluating or solving log problems. Okay, I got one more type of problem to do with you guys. Okay, so let's do that one here. And the topic or the way the directions on the worksheet, it's going to say simplify. Okay, so let's do that. Simplify. And it's going to say log base 2 of 32. Now, what I'm going to do is, I know it says simplify, but what I'm going to say is solve. And you're going to be like, well, Mr. Carvers, how do you solve when you don't have an x? Watch. Ready? Watch this. Equals x. What? You can just do that? Well, yeah. I just need to know what log base 32 is, log base 2 of 32. So let's set it equal to x and then just solve for x. It's the same thing. So if you set it equal to x, then it's like every problem we've done already. Okay? So you need that x. And then it said, now you're going to rewrite as an exponential. Okay? So let's rewrite that as an exponential. It's 2 to the x power equals 32. Now, it's a little tricky, guys, but I want you guys to understand that that 32 can be written as something to some power. Okay, it's usually going to be a 2 to some power, or maybe a 3, or a 4, or a 5. Okay, probably not more than that. Maybe a 6 or 7. Maybe. But it's usually something 2 to the something power 3. And notice this is 2 to the x power. I need to find out what this is 2 to something. I need these numbers. I'm going to make this a little bold here. I need these numbers to be the same, guys. This 2 and this 2. So try it in your calculator. Type in 2 squared. Well, that's 4. How about 2 cubed? Oh, that's 8. How about 2 to the 4th power? Oh, that's 16. How about 2 to the 5th power? That's 32. Oh, that's 32. So 2 to the 5th power is 32. So I want you to write 2 to the 5th power here. And that's 2 to the x. These need to be the same. These values need to be the same. Because if they're the same, I don't even have to worry about them anymore. Literally, you're setting that equal, I should really circle this one equal to this. So your answer is x equals 5. That's the answer to that problem, guys. It's actually easy to do this, but that 2 has to be equal to that 2. It has to be the same number. And then you set the exponents equal to each other. You don't even have to worry about the 2 anymore. The 2's out of there. Once you've set those equal to each other, they're out of there, and you just set the exponents. So you set exponents equal. Okay? That's it. So let's try another one here. And again, the directions are going to be simplify. So simplify. If I said log base 4 of 64. So the first thing you're going to do is you're going to set it equal to x, because I need to solve for x, and you're going to write it as 4 to the x equals 64. So then you're going to go, I need a 4. So I'm going to start on the side here, and I'm going to go, let's see, well, 4 squared is 16. What about 4 cubed? That's 64. So you're going to write 4 to the x equals 4 to the third power. These are the same. So you literally just deal with the exponents. X equals 3, and you're done with the problem. Super easy. Okay? So if I give you one other last one here, okay, and if I said log base 7 of 7 to the 8th power. It looks a little nasty, but here's the deal. We're going to set it equal to x, and then we're going to write it as an exponential. So this 7 to the x power equals 7 to the 8th power. Now the beauty is I don't have to do any work, guys. The reason I don't have to do any work is because that's already got an exponent. So literally, because these are the same, you set those equal to each other, and my answer is x equals 8. That's pretty sweet. Okay? So that's basically how you do the kind of problem you're going to see in your worksheet. That's kind of the intro into logs, converting it between exponential and logarithmic, and back and forth one to another, and then solving, okay, and then simplifying. If I just give you log base 2 of 32, how to simplify that. Okay. Tomorrow I'm going to show you kind of another fancy way, and you're going to be using your calculator a little bit more to help you solve these log problems. Okay? So that's it, math fans. You guys have an outstanding day. Adios. Goodbye.